Let's do another example of a two-proportion z-test, and the reason that I wanted to do this example, this is an observational study rather than an experiment, and the actual calculations don't differ. We just write about it slightly differently, and I wanted you to see a context where you had to be at least a little careful organizing the information. So this is current data, this is real data. So in a Gallup poll conducted between the 13th and the 22nd of 2020, 1,020 randomly selected adults living in the US were asked the question, do you approve or disapprove of the way Donald Trump is handling his job as president? So this is a presidential approval poll. These polls have been done since the days of Harry Truman. So between the 13th and the 22nd, when this survey was done, 500 said they approve. And in a Gallup poll then conducted between the 1st and the 14th of April of 2020, 437 of 1,017 randomly selected adults living in the US answered approve to the same question. So based on these data, is there evidence? And of course, we know that the sample percentages that we've seen are different. That's not the question. The question is there evidence that the percentage of all adults, so if the parameter is the proportion of all adults living in the United States that approve of the way Donald Trump is handling his job as president, do we have evidence that the percentage for all adults that approve how he is handling his job, do we have evidence that that has changed during the COVID-19 crisis, in this case from March to April? So the first thing that we should do is define our parameters. So P March. So let's say this is the proportion of US adults. It's actually adults living in the United States. So we'll call this the proportion of adults in the US that approve of Trump's job. So, but technically that's in March. Technically, it's March between the 13th and the 22nd. And P April, we can literally just copy it here. This will be the proportion of adults in the US that approve of Trump's job, how he's handling job as president in April. So the null hypothesis, if there's nothing special going on, if we're looking for evidence of a change, so if there is no change between March and April, then we would expect the percentage or the proportion in March to equal the population proportion in April. So those two being equal, another way to write that is equivalent to saying that the difference between those equals 0, and that's typically how I write it. You could write it either way. So the reason we write it as a difference is because a few units ago, we actually found the sampling distribution for the difference between proportions. So that's why we typically write it this way. So the alternative hypothesis is we are not looking for a direction necessarily. We're just looking for evidence of a change or a difference. That's a not equal to alternative. So the alternative hypothesis, you could write it, and you don't have to write it both ways. You could simply write that the proportion in March is not equal to the proportion in April. That's equivalent to writing it this way. This is the way you'll see me write it going forward. So the proportion in March minus the proportion in April, not equal to 0. Again, the not equal to comes from the fact that we're looking for evidence of a change. So maybe the hardest thing to do here is to get the data organized. So the sample proportion from March. So up here, the question starts with data from March between the 13th and the 22nd. If you read it, 500 is the number of successes, and that was 500 out of 1,020. 500 successes out of 1,020. Then in April, we had 437 successes out of 1,017. So those are, 1,017. So these are the sample proportions from March and April. We are not going to bother with the combined sample proportion. That's needed only if we calculate the p-value by hand, and that's something we did in the previous example. We're not going to do that here. So this is an observational study. So there isn't a treatment group and there isn't a control group. This isn't a situation where I'm applying a treatment to subjects and then looking for a change in a response. I'm not randomly assigning to a treatment and a control group. So because this is an observational study, the randomness condition is a little bit different here. What we need are two independent random samples. So I need two random samples, and I do have two random samples. One of them is from March and one of them is from April, and what makes them independent of one another is specifically that. One of them came from March and one of them came from April. So it is important to say then we don't have random assignment to treatment and control groups. This is not an experiment. Observational study. So we should say is we have two independent random samples. Two independent random samples of adults living in the US one from March and one from April. There we go. So now, because we have randomly selected from a population, that population from March and that population from April are the population of adults living in the United States, now we do have an independence condition to check here. So if we, in March, if we take 10 times the sample size in March, which was 1,020, so that makes 10,200, and certainly that's less than or equal to the number of adults living in the US. In March. So, in other words, what we're saying is the 1,020 adults, because we're sampling such a small number from the overall population, we can act as if those 1,020 adults are independent of one another. So whether one adult approves is unlikely to affect whether another adult approves, because they're unlikely to know each other, be in contact with one another, be able to influence one another necessarily. So the independence condition is talking about independence within the sample from March, and same thing, we can act as if the subjects within the sample from April are also independent of one another, because if we take 10 times the sample size from April of 1,017, that's 10,170, and again, that's certainly less than or equal to the number of adults living in the US in April. So we have independence within the two samples, although understand up here, it's important to say that the two random samples are also independent of each other. That's what allows us to combine the proportions together as a difference. So we need those two random variables, the sample proportion from March and from April, to be independent of one another so that we can combine those two random variables together as a difference and have confidence in the sampling distributions formula for the standard deviation. So it's important that you mention independence. Both the random samples have to be independent of one another, and then within each random sample, the subjects within the March sample should be independent of one another. The subjects within the April sample, they should also be independent of one another. And now we need normality for the March and April samples, and that's not a problem. So the number of successes in March was 500. and that's certainly greater than or equal to 10. So the number of failures in March would be the 1,020. Take away 500, and that's no problem. That's 520. That's certainly greater than or equal to 10. Same thing for April. So in April, we had 437 successes. That's greater than or equal to 10. And if we take our sample size of 1,017 and subtract the 437, that gives us 580 failures. No problem. So test name, just like the other example, this is a two-proportion z-test. So now we just need to come up with our test statistic and our p-value, and this is interpreted like any other test of significance. So it is a two-proportion z-test, so you have to go to find a command that starts with two-prop, and we want z-test. So here the number of successes, I will enter March 1st and April 2nd, and I will do it that way because that's the way that I specified my null and alternative hypotheses. So here are the number of successes and the sample size from March, number of successes and sample size from April, and that's exactly, those are the values and the order in which we will enter them into the calculator. So 500 successes in March out of a total of 1,020. Then in April, we had 437 successes. That's out of a total of 1,017. So here we're looking for a two-sided alternative. We're simply looking for evidence of a difference. So there is our z-score. The z-score is 2.739, and our p-value is 0.006. So our test statistic is a z-score that was 2.739. And the p-value is approximately 0.006. So this is a statistically significant result. In other words, yes, I know that the sample proportions are different, but are they different enough from one another? Is that difference large enough for us to believe we have evidence that the actual proportions of approval from March and April in the populations are different? And the answer is yes. So if the proportions are the same in March and April, a difference as or more extreme than what we've observed in our sample data. So a difference that results in a z-score of 2.739 or higher, or negative 2.739 or lower. In other words, a difference that's more than 2.739 standard deviations away from the mean. That far or farther, that percentage or that probability is only 0.006. So this is an unlikely outcome if the null hypothesis is true. It's unlikely to see a difference of sample proportions this extreme or more extreme if the null hypothesis is true, if the population parameters are actually equal for March and April. So that's why we have evidence to reject the null hypothesis here. So with that p-value of 0.006, and that's well less than our level of significance, that's what we call alpha, or 5%. So this is an unlikely outcome, so we do reject the null hypothesis. And you can write out null hypothesis, or you could simply write HO, that's fine. So then we have evidence, and this is an example where we can just copy the words from the stem of the question. We have evidence, and you can copy the words, that the percentage of all adults in the US that approve of how President Donald Trump is handling his job has changed during the COVID-19 crisis. So it's changed, if you will, from March to April. So I'm just going to copy the words. We have evidence. Make sure when you've compared your p-value to alpha, and once you've said whether you reject or don't reject the null hypothesis, do not write about the null hypothesis anymore. The conclusion is always written about having or not having evidence of the alternative. So we have evidence that the percentage or the proportion, the percentage of all adults in the U.S. that approve instead of taking the time to write out that phrase, how President Donald Trump is handling his job, I will just say that approve of how Trump is doing his job. I'll just keep going. That approve of how, it is actually a good lesson to copy the words, of how President Donald Trump, we'll just abbreviate it, President Trump is handling his job. Has changed. So we have evidence that the percentage of all adults in the U.S. that approve of how President Trump is handling his job has changed. Now, the way I wrote the question was during the COVID-19 crisis. If you want to be more specific than that, you can say has changed from March to April. That would be fine. So that is an example of an observational study. So the one thing to consider, if you are working with an experiment with random assignment to treatment and control groups, you write the randomness condition a little bit differently, and you don't have to check the independence condition. In an observational study, again, you write the randomness condition a little bit differently, but in an observational study, because you are actually taking a random sample from two populations, you want to make sure that you write about your independence condition because you are sampling from within populations. So you want the subjects or the experimental units, the observations from each of those populations to be independent within each of those samples from the population. So the point is, knowing whether you have an experiment or an observational study just slightly changes the way that you write about the conditions.